Hello guys, my name is Sebastian and today I'm going to be talking about my particular project within frequency response and I'm going to be looking at two circuits today and I'm going to just go ahead and start off with this first circuit. So first I'm going to go ahead and break down my circuit. I have my voltage source right here. I have my first resistor and another resistor. My first resistor having a value of 9K or 9 kilo ohms, and my second resistor having a value of 1 kilo ohm, and my capacitor having a value of 0.22 microfarads. And today, what we're interested on looking at is the Bode plot for this specific circuit. And to begin, because this is what we're going to be doing for the first and second circuit, a Bode plot is basically the graph of the frequency response um, to this particular circuit or the next one that we're going to look at. And it'll usually have the Bode magnitude and the phase. Um, and so we can actually go ahead and see that right here on the as I run it. So let me go ahead and run it and let me show you all. So, and basically what we're interested on seeing is this, we're interested on this part of the circuit, mainly right here on my output. We're trying to see what V out looks like. So let me go ahead and run it, and let me put my probe over this area. So if I put our probe right there, we can actually see, and we get a display. This solid line right here, or this solid part of the graph, is my Bode amplitude, and this dashed line or dashed graph right here is going to be my phase of the Bode plot, or another name for it would be the Bode flip phase. And this is basically what we're looking at, and that's specific to this circuit. Um, so it's a very interesting graph as we can see, um, and it's really cool that we get to go ahead and that we're able to analyze this this circuit deeply using the software, and we're able to obtain those graphs that other ways we would do by hand, right? So yeah, that's how we obtain this. Another way to obtain this would be to take the transfer function of this circuit and go ahead and use MATLAB and implement your transfer function in there, and we would obtain the exact same graph. Uh, so now let's go ahead and move on to the next circuit. So my next circuit is actually a non-inverting circuit, but just because I could not find the specific package, I had to actually just intervene and do some different things. So as you can tell right here, I have my input. I'm giving it a sine input. I have my resistor grounded right here on this side. And again, I'm interested in finding the Bode plot of this circuit. Um, Here I'm giving it plus 15 volts, and here I am giving it negative 15 volts on this side, right? So pretty much, yeah. So pretty much, this is the circuit. It's supposed to. We got this circuit, and we were supposed to go ahead and do what we did before, and which is analyze, obtain the Bode phase, and obtain the Bode magnitude. So let's go ahead and see what this gives us. Let's go ahead and run it. And again, we're interested on this particular side. So let's go ahead and put the probe down. And again, right, we can go ahead and tell right here, right, that we obtain this dashed line, which is our Bode phase, and we go ahead and obtain our Bode magnitude, which is represented by this solid graph or solid line right here, solid curve. And pretty much that's it. I just wanted to demonstrate how I was able to obtain the graphs and simulate my circuits. And again, we can actually go ahead and take the transfer function by analyzing this circuit. We would obtain the transfer function, and we can go ahead and evaluate it and use MATLAB to go ahead and obtain the same graph or analyze it even further. But thank you for joining me today. Thank you.